Alright, so we're going to talk about fitting a line to a set of data. So when we do fit a line to data, we're looking at what we call a scatter plot. So you may remember what a scatter plot is. A scatter plot is when we have a coordinate plane and we have graphed points on that coordinate plane looking to see if they show any type of pattern or not. Okay, so I'm going to put several up here. And we're going to talk about what those patterns mean. So do this one maybe that looks like this, and another still maybe that, we'll let this one be kind of all over the place. Okay, so what we're looking for is we're looking for a relationship between the points. Now if you look, they look like they're closely scattered together here in maybe a line that would look something like that, or maybe let's see, that's probably a little bit better representation. Or here, maybe it looks almost like they follow a pattern that looks like a line. So this pattern is what we call correlation. Okay, and so if it looks like it's following a line up, we say that it has positive correlation. If it looks like it's being modeled by a line that goes down, we say that is negative correlation. And I know I'm all over the place here, but if you look at this first one, how it looks like it's everywhere, there's no relationship here, we would say that that has no correlation. There's not a line that you could use to represent that data. All right, so let me show you a couple of examples, and I want you to describe the correlation for me. Let's first look, let's say we looked at something that compared how long you study to the grade you made. Hours studied to your grade. Okay, and let's say whenever I plotted this data, that I noticed it looks like this. So what I would like for you to do is to take a look at this and describe the correlation for me. So I hope as you looked at this, you noticed that it looks like a line with a positive slope that is increasing. Therefore, I would say that this data has a positive correlation. Okay, let's try one more together. Let's look at if I compare, rather than hours studying to test scores, let's say I compared hours watching television to test scores or grades. We'll say grades. Okay. And let's say I noticed a pattern that looked like this. And I'm not putting specific values on here. If you would just, we'll get to that shortly. But I want you to describe the correlation, if there is any correlation, in this set of data. So I hope you notice it looks like a line with a negative slope, which would indicate negative correlation. Okay, so that's correlation. Okay, so what I'd like to do is I'm going to give you a set of data, and I already have it set up here, so if you'll take a second to copy it down, you may want to pause the video or do what you need to do so that you can copy it. And we're going to do two things with this. First thing we're going to do is we're going to make our own scatter plot. And then we're going to talk about the correlation of those points. So we're going to describe the correlation. Okay? And then we'll do a little something else with it in just a minute, and I'll tell you what that is. But first, let's look at this data and let's see if we can plot it. So let's get a coordinate plane set up. Okay, so you want, because we're talking about real-time data, we're only going to do the first quadrant. So we'll have positive x and positive y. We'll do something about like this. Okay, so we'll let the length be our x-axis here. And we'll let the speed be our y-axis. And so let's see, we need to go up to at least 30, it looks like, on our length. So maybe we'll go by 5 maybe. So we'll let this be 10. Well, let's go by 2's. 2, 4, 6, 8. 4, 6, 8, 10. 2, 4, 6, 8. 20, 2, 4, 6, 8, 30, and I'm just trying to help you in how you would want to best set this up as you go. 4, 6, 8, 40. All right, and for the speed, we want to take it up to, looks like the biggest speed in that set of data would be 148, so maybe up to about 150. So maybe we'll go by, let's go by 20s. 20, 40, 60, 80, here's 100. 20, 40, 60, 80, here's 200. Okay, so whatever units you feel like would be best on your graph, go ahead and set that up. And I'm just marking these. It'll be a little bit easier for me as I go through plotting these points. Okay, so for the first point, the pike, I have 37.8. So 32, 4, 6, 37 is about in the middle, so somewhere around here up to 148. So close to, let's see, 150. Right about here. Okay, so let's continue to plot these points. 19.2. I'm now on the red Gernard. 19.2 up to 47. 20, 40. So somewhere around here. And then for the black bass, 21.388. So, I'm sorry, 21.8 is almost 22, up to 88, 20, 40, 60, 80, about almost to 90. We're just doing a little estimate, trying to get as close as we can. Then I have 26.2, so 26 up to 131, 20, 40, 60, 1, 20, 30. And if you need to use a ruler to kind of line up, do that. And then the Norway haddock, I'm at 26.8. So 20, 22, 24, 26. So right here, 98, 20. Okay. So now we have graphed our scatter plot. So the question is, does this show any correlation? And if it does, what correlation does it show? So take a minute to look at that and see. And I hope you see from this that it does in fact show correlation, and the correlation that it shows looks like it has a positive correlation. Okay. So we're going to take this just a step further now, and we're going to take our scatter plot that we've made, and we are going to use that to estimate a line that would represent our data. So what we call this particular line is a line of best fit, okay? And what that means is it's the equation of a line that best represents our set of data. If I can write it correctly. Peter's thinking about it. Okay. The equation of a line that best represents a set of data. So if you look, what we were doing before, we've been putting the lines on there. We've just not been finding the equation of those lines. So I want you to think for just a minute. If I need to write the equation of the line, remember I need two things. I need either 2 points or a point and the slope. Okay? So either one of those two things will allow me to write the equation of the line. So if you look, I've kind of drawn this line, and the key I will tell you to drawing a good line of best fit is that it has approximately the same number of points above it as it does below it. Same number of points above and below. Okay, so if you look at this line we were just looking at, it looks like there's 2 above and there's 3 below, and that's a pretty good estimate since there's only a total of 5 points to start with. Okay, so let's go back forward here. So what I would need to do when I write the line of best fit, okay, I want to first draw the line. So let's do some steps here, and then we'll actually apply it, and I'll let you try it. Line of best fit. First thing I want to do is actually draw the line, and we want to draw it the way we talked about just now, in that we really want the same number of points above and below the line. Okay. Then what we're going to do is we're going to choose 2 points on that line, any 2 points on that line, but 2 points, not 2 data points. There may be some, but what I want to do is I don't want to just choose 2 random points because those might not lie on my line. Again, if I go back, if you look at my line of best fit that I drew when I did the fish, none of the data points actually lied on that line. You see they were all, so if I use this point and this point, what's going to happen is it's just connecting those 2 points, and that's not what I want to do. I want to do a line that best represents all of the data as a whole. So this is not a good representation of the data because that's not what it looks like. Okay, so I want my line to follow the data as I go. All right, so 2 points, not data points, but 2 points on the line that I draw on there. And then from there, I'm going to write the equation the way I know to write an equation, which is finding the slope and plugging into point slope form. Okay, so what I'm going to do, I'm going to give you a set of data. And what I would like for you to do is I would like for you to make a scatter plot on your paper and describe the correlation and draw the line of best fit. Okay, and I'll give you just a second to do it. Or actually, let me give you this first. Let's do, I guess that would help, huh? Let's do one. We'll make this easy. We won't make this a word problem or anything so that we can, for the sake of time here. 4. We'll do 5, 5 and 6. And we'll do 2, 3, 4, 4, 5, 5, 5, 7, 8. So if you'll take just a minute to plot those points and draw your line of best fit, and then we'll come together and write the equation for the line. Alright, so as I graph these, and let me put a grid on here so you can kind of see what we're doing. And I'm just going to do it right here below so we have this data all on the same page. We'll have, let's contrast that color a little bit. Let's do a white. Here, and let's plot these points. Let's see, 1, 2, 1, 3, 2, 4, 3, 4, 3, 5, 4, 5, 5, 5, 5, 7, and 6, 8. Okay, so I think the best line of fit, let's see how we can go through this to represent. I'm going to say something along that looks pretty good. Okay, and that kind of follows the data. Maybe yours, maybe we could bring it, let's see. Maybe that looks a little bit better, okay? So I want you to take just a minute and tell me how your line looked. Is it the same as mine? Does it look similar? Describe how your line differs from mine. And this is where you're going to learn that everybody's going to have a different equation. Okay? So, let's pick 2 points on here. I'm going to pick, let's see. This looks pretty close. Let's do, and this is not a data point. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 6, 6. And then I think I'll do this point, which is 0, 2. Okay? Notice how I picked 2 points that were on my line. I want you to pick 2 points on your line. Make them different than mine. Okay? And you give me the coordinates of your 2 points. Okay, so let's take our 2 points now. Let's do 0, 2 and 6, 6, and let's find an equation of the line that goes through those 2 points. So remember, I'm going to do slope first. So y2 minus y1 over x2 minus x1. So I have 6 minus 2 divided by 6 minus 0. 4 over 6, which is 2/3, right? So now when I plug that into point slope form, I get y minus, and I'm going to just use this first point, 2 equals slope times x minus 0. And you can leave it just like that. So you tell me, what's your equation for that line?